Well, welcome to this online revision session for AQA FP3, in which we'll be looking at the June 2010 question 2 on the solution of second order differential equations. Well, you can see in the first part of this question we're given a second order differential equation and we're asked to find a particular integral, and we're given the form of the particular integral as k sine 2x, so we've got to find the value of that constant for it to be a solution. And then going on from that, we then have to find the complementary function so that we can obtain the general solution to this differential equation. So in the first part of this question then, we're going to use the particular integral as y equals k sine 2x. So we need to find the second differential to be able to substitute it into this differential equation. So if we find dy by dx, that will give us 2k cos 2x. Remember, differential of cos is, sine is cos, and then we've got to differentiate the 2x, which gives us the 2 in front. And then we get the second differential, differentiated again, differential of cos being negative sine, so this will become negative 4 from differentiating the 2x, sine 2x. So if we now substitute into this equation, it's going to give us minus 4k sine 2x plus k sine 2x equals sine 2x. And of course from there we can see that the sine 2x is common all the way through this, so if we equate the coefficients we're going to get minus 4k plus k equals 1. So minus 3k equals 1. So the value of the constant that we obtain is therefore negative 1/3. And we get 3 marks for doing this. So for attempting this substitution, we get 1 mark. For having the correct expression at this point, we get an additional mark for our accuracy. And then for obtaining the correct value for k, gives us our 3rd mark. Moving on then to finding the general solution, we've got to find the complementary function. To find the complementary function, if you remember, we solve this equation d2y by dx squared plus y when it equals 0 by using the auxiliary equation. So firstly we will write down the auxiliary equation. So in this case we've got one lot of d2y by dx squared, so we get one lot of m squared. There is no dy by dx's and just one lot of y, so our auxiliary equation reduces to m squared plus m equals 0. Which therefore implies when we solve that m is equal to plus or minus the square root of minus 1, which we know is plus or minus I. So we have a complex solution. And you remember the complex solution then implies that our complementary function will be equal to some multiple a of the cosine, and similarly plus b sine and the number of x's involved is determined by the coefficient of the plus or minus I. Well, there's only one I in this case, so this will just become a cos x plus b sin x as the complementary function. Having got that result, we can then find the general solution, because the general solution is the complementary function plus the particular integral, and that was found in the first part, and so our general solution becomes a cos x plus b sin x minus, remember k was negative a third, so it's minus a third of the sine of 2x. 4 marks for this will come from a statement obtaining the values from our auxiliary equation, 1 mark, and then we're writing down the correct complementary function, or an attempt at that function, and then an accuracy mark for following through from your solutions to the auxiliary equation into that complementary function. And then finally, stating the general solution correctly from your results gives you your 4th mark. Hopefully you found that solution helpful. For more support to your maths revision, please go to the Further Maths Support Programme website.